Okay, here's video number 2. This is Algebra 1, Lesson 4.4, Percent Change. This is a very short lesson. So this video is going to cover 4.4 and 4.5. So you're going to have these handouts that you'll work on by yourself. You'll stop the video and you will work these problems on this handout. I'll bring it to you during study hall. First thing you need to know is that percent change is the amount of change you're going to figure out how much it changed. So it means you're going to do a subtraction problem over the original amount. Make sure when you start your problem that you put the original amount on the bottom. Okay? That has to go on the bottom. That's something that kids forget sometimes. Let's look at example A. The price of a sweater decreased from $29.99 to $24.49. So the first thing you have to do is you have to find the amount of change. So that means you're going to do a subtraction problem. $29.99 minus $24.49 over the original amount. I would circle that first number every single time so that you know it goes on the bottom. Okay, here we go. $29.99 minus $24.49 is $5.50. So this is equal to 5.5, which is $5.50 over $29.99. Now, you need to divide the top by the bottom. And we are going to get 0.18339444648. That's what my calculator shows. Now, this is one of those situations where you're going to have to change that to a percent. Okay, you're going to have to change that to a percent. So I want you to multiply it by 100. All that does is move the decimal 2 places. And the instructions, if they say round to the nearest percent, that's going to be 18%. Okay? That's option 1. Option 2 for working this problem is to take this 5.5 over $29.99 and set it equal to percent over 100. And then cross multiply. You get 550 equals $29.99 times the percent. So you divide by $29.99. And you get, same thing we got, 18%. Okay? I'm going to use method 1. Okay, because I want to teach you this lesson where we're multiplying by 100 at the end to get our percentage. But if you're just in love with the ratio method, you go back and you use that if that's what you like. Okay, so I want you to stop the video and I want you to work this problem about the skateboard. And I want you to do it whichever method you prefer. Okay, next example from lesson 4.4. It says the price of the CD decreases from $12.99 to $13.99. So this is the one I'm working right now. Oh, let me tell you something I forgot to say. This said decreased, but we want to put a D beside that 18% to make sure we know it decreased. So go back and do that if you need to. Okay. Type B, the price of the CD increases from $12.99 to $13.99. So I need the amount of change. It went from $12.99 to $13.99. So to find the amount of change, I'm going to do $13.99 minus $12.99. The larger number minus the smaller number because I want it to be positive. And I get $1. The original number was $12.99. Okay? Now, at this point, you can take that dollar over $12.99 and you can set it to P over 100. You can solve it that way. I'm going to divide $1 divided by $12.99 and then I'm going to multiply by 100 And my percent change is, I'm going to round it this time to the nearest tenth, 7.7%. Was it an increase or a decrease? It went from $12.99 to $13.99. It increased. Now I'm going to work this one. What happens if we turn around and we decrease the price of that CD by $1? Don't just think it's 7.7%. It's not. Be careful here. How much does it change? Well, it changes the exact same amount, doesn't it? It changes $1, but what's different is the original is $13.99. It was $12.99 up here. It's $13.99 in this problem. So you can either set your $1 over $13.99 equal to P over 100, or I'm showing you how to work it on the calculator this time. $1 divided by $13.99 and then multiply by 100. Round it to the nearest tenth of a percent. This is 7.1%, and it is a decrease. Okay? Are the percent change values the same in these two problems? No. Why or why not? No, they're not the same. Why? What's different? The amount of change is the same, but what's the different part? The original, ORIGINAL, the original price is different. So you get a different answer when you divide. The original price is different, so you get a different answer when you divide. Okay. So now I want you to work this problem from your handout. That is 9.5 billion. That is 725.3 billion. Find the percent increase. Okay? It doesn't matter that it's in billions. You're still going to find the percent increase. It's still going to work out for you. Okay. We're going to go right ahead. I don't think y'all are going to have any trouble with that other lesson. So we're going to talk about probability, because I don't think you're going to have any trouble with this either. And this is lesson 4.5. Our first thing we need to talk about, I think I have these out of order. Here's 4.5. Okay, I'm ready to go now. Got my life together. It says here, probability. Probability is how likely something is to occur. The outcome is the result of a single trial. If you are rolling dice, or if you are flipping a coin or something like that. The event is the group of outcomes. If I tell you to flip a coin 10 times, the event is flipping the coin 10 times. What you get on the first flip is your outcome. You'll have 10 of those. The sample space is all the possible outcomes. If you're flipping a coin, the possible outcomes are either heads or tails. If you're rolling a dice, the possible outcomes are 1, 2, 3, 4, 5, 6. 11 is not in the sample space of rolling a dice because it's not on the dice. If I told you to roll 2 dice and add them together, our sample space would become all the numbers from 2 to 12. But our sample space are the possible outcomes. Now, there's two kinds of probability. Both of them you think about the very same way. The first is theoretical. It's the number of favorable outcomes over the number of possible outcomes. This is what's supposed to happen when you flip a coin. It's supposed to be 50% heads and 50% tails. Experimental probability is the number of times your event occurred over the number of times you did the experiment. If you really flip a coin 10 times and 7 times it lands on heads, then 7 out of 10 is your experimental probability. The experimental probability comes from actually doing an experiment. Okay, let's answer a few questions here. First question says, a bowl contains the months of the year. Find the theoretical probability that you draw a name with J as the starting letter. That's hard to read, but that means J is the starting letter. So what are the options there? January, June, and July. 3 out of, how many months are there? 12. Simplify your fraction. 1/4. Now it says find the theoretical probability that you draw a name that does not start with J. Well, if 3 of them start with J, how many of them don't? 9. So 9 out of 12, which is 3/4. Now add these two probabilities together. 1/4 plus 3/4, is that equal to 1? Yes. These two events are called complements of each other. If together their probabilities add up to 1, if together they cover all of the possible things that can happen, then they are complements. Okay, I want you to go to your handout and I want you to answer this question. It says find the theoretical probability that you choose a month that ends in "ber." Okay? And then find number cube has these numbers on it. Find the theoretical probability that you roll a number not divisible by 3. Answer those questions for me on your homework. Here we talk about those two probabilities were complements. Their sum was 1. Another example, on a game show, you choose an envelope that contains a grand prize. One envelope contains a car, the other envelopes contain less valuable items. What's the probability of not choosing a car? On a game show, you choose an envelope from 5. There are 5 envelopes. One contains a car. What's the probability of not choosing a car? Well, if one contains a car, 4 does not. So that probability is 4/5. Okay, I want you to stop the video and I want you to find a coin. I want you to toss it 10 times and record the results. You just conducted an experiment. What was the probability of it landing on heads? Experimental. That means if you flipped it and 3 times it landed on heads, it's 3 out of 10. If 7 times it landed on heads, it's 7 out of 10. Then tell me the experimental probability of it landed on tails, and then I want you to add them together and tell me what you get. One last problem we're going to look at. It says the experimental probability of an iPhone not breaking is 98%. That means that 98 out of 100 do not break. Use that information to predict how many will break in a batch of 5,000. Well, how many will break? If 98 do not break, how many do break? 2 out of 100 break. You've got 5,000. So I want you to solve. That's going to be 10,000. 100 and divided by 100. And I get n is equal to 100. 100 will probably break. Okay, answer these last two on your handout, and I'll see you in class tomorrow.